is Ashli Mann, and I'm going to be talking about how to create an alcohol using a Grignard reagent. A Grignard reagent is a molecule in which magnesium is bonded to some type of carbon in either a chlorine, bromine, or iodine. This reagent is unique because magnesium is less electronegative than carbon, giving carbon a partial negative charge, which allows carbon to behave as a nucleophile. This is rare because typically carbon has a partial positive charge. A Grignard reagent is formed when magnesium inserts itself right in between a carbon and a halogen in a carbon-halogen bond, as seen here. As you can see, originally the carbon has a partially positive charge, and when magnesium was inserted, the magnesium now has that partial positive charge, while the carbon has the partially negative charge. As you can see, the solvent used to create the Grignard reagent is an ether solvent, and I will explain why this is important. Grignard reagents will behave as very reactive bases in the presence of even mildly acidic protons. Therefore, it is very important that when you are working with a Grignard reagent, you do so without the presence of any type of acidic proton. Grignard reagents will even react with the protons on water molecules from moisture in the air. If this happens, you will not be able to successfully create a Grignard reagent because as soon as it forms, it will be destroyed. Therefore, Grignard reagents are created in an ether solvent such as diethyl ether or THF. For this same reason, when creating alcohols using Grignard reagents in a Grignard reaction, it is important to maintain an anhydrous environment as well. Otherwise, the Grignard reagent will be destroyed. When thinking about Grignard reagents and reactions, it is best to think about them in 3 different steps. Step 1. Create the Grignard reagent from a carbon-halogen bond reacting with magnesium in an ether solvent, ensuring an anhydrous environment. Step 2. Nucleophilic attack. The Grignard reaction occurs when a Grignard reagent reacts with a carbonyl-containing compound. It is still important to make sure that this is in an anhydrous environment. Step 3. Proton transfer. Finally, it is a safe time to add a protic substance such as H3O+ into the reaction, creating the alcohol. When setting up a Grignard reaction, remember to always list the Grignard reagent as step 1 and the protic substance as step 2 in a Grignard reaction. As we've talked about, if you add them both at the same time, the Grignard reagent will be destroyed and the alcohol will not be formed. In a Grignard reaction, the carbon attached to the magnesium behaves as a nucleophile and attacks the carbonyl-containing carbon on the ketone. This results in an addition reaction in which the carbon chain from the attacking carbon is added onto the carbonyl carbon. This pushes electrons to the oxygen on the ketone, breaking the double bond and giving the oxygen a -1 formal charge. At this point, since the Grignard reagent is already broken up, it is safe to add a protic substance, in this case, H+. The oxygen will attack that proton, forming the alcohol. As shown in this Leah Forsai study sheet, Grignard reagents react very well with various types of carbonyl-containing compounds to create a variety of alcohols. The exception, though, as you can see, is carboxylic acid. This is because of the acidic proton on the hydroxyl group present on the carboxylic acid. Remember, in the presence of even a mildly acidic proton, a Grignard reagent will behave as a base and attack that proton via an acid-base reaction. This results in the same carboxylic acid as the starting material being formed, rather than an alcohol forming on the carbonyl group as desired. This is true of any molecule with a hydroxyl group present along its carbon chain. So what can we do if we want to create an alcohol using a Grignard reagent from a molecule with a hydroxyl group present? We use something called a protecting group. The protecting group shields the hydroxyl group to prevent the Grignard reagent from reacting with the proton. In order to do this, the protecting group needs to be something that is easy to get on and easy to take off. One compound that is great at this is trimethyl chloride. Once we put the protecting group on, we must also take it off. This is commonly done using tetrabutyl ammonium fluoride, as shown on the screen. The mechanism for putting on and taking off a protecting group is a bit complicated and would be best explained in its own video, so we're just going to think about it in 3 steps. Step 1. Deprotonate the hydroxyl group in order to form a protecting group compatible with the Grignard reagent. Step 2. Perform the desired Grignard reaction. Step 3. Deprotect the hydroxyl group by converting the protecting group back into the original hydroxyl group. And there you have it, a way to use the Grignard reagent to form an alcohol in the presence of a hydroxyl group. So putting the whole picture together, you create the Grignard reagent, you perform the Grignard reaction, being careful to keep the solution anhydrous until step 2, at which time the alcohol is formed. If there is a hydroxyl group present, a protecting group must replace the hydroxyl group until the Grignard reaction is complete. Once the alcohol is formed, the protecting group must be removed. I hope this video was helpful in understanding alcohol synthesis using a Grignard reagent. Thanks everyone. Goodbye.